Bayesian shrinkage changes the rating. There's another philosophy: don't touch the rating at all. Instead, change how much you trust it. Limma-voom takes the weighted approach. Restaurant A keeps its 5.0 average untouched. But when comparing restaurants across the city, the 2 review restaurant gets a weight of 0.1. Its opinion barely counts. The 500 review restaurant gets a weight of 1.0, full confidence. The rating isn't changed. The influence is. In limma-voom assigns precision weights to each gene. Low count genes get low weights, their fold changes are barely considered. High count genes get high weights, their fold changes dominate the analysis. The data speaks, but quietly for unreliable measurements and loudly for reliable ones. The precision weight is the inverse of the variance. A gene with high read counts has low variance, its expression estimate is precise. The weight is high. A gene with low read counts has high variance, its estimate is noisy. The weight is low. It's like the difference between a restaurant rated by 500 independent reviewers versus 2 possibly biased reviewers. The 500 review estimate has low variance and high precision. When the weighted linear model fits the data, high weight observations pull the regression line. Low weight observations barely register. The voom function estimates the mean variance relationship. Plot the average expression of each gene against the square root of its standard deviation. The relationship is smooth and predictable, a curve descending from high variance at low expression to low variance at high expression. Voom fits this curve and assigns each observation a weight equal to 1 over the predicted variance. The curve is the weighting function. A gene at the high expression end of the curve gets high weight. A gene at the low end gets low weight. After weighting, the data behaves as if every gene were measured with equal precision and standard linear modeling tools apply. Both approaches reach the same destination by different routes. The Bayesian approach DESeq2 changes the rating itself. 5.0 becomes 4.1 through shrinkage toward the prior. The weighted approach limma-voom keeps the 5.0 but assigns it a weight of 0.1 in the comparison. When you rank all restaurants by their adjusted influence, both methods agree that the 500 review restaurant at 4.2 is more reliably good than the 2 review restaurant at 5.0. In practice, DESeq and limma-voom agree on which genes are differentially expressed about 85 to 90% of the time. The disagreements are usually borderline genes near the significance threshold. Edger offers a third approach, a blend of both philosophies. It estimates dispersion per gene, each restaurant's inherent variability, then squeezes those estimates toward a common value using empirical Bayes. This is like estimating each restaurant's review variability and then pulling extreme variabilities toward the city average. Posse likelihood F-test then accounts for the remaining uncertainty in the dispersion estimate itself, acknowledging that even the squeezed variability isn't known perfectly. Not pure shrinkage of the rating, not pure weighting of the confidence. A third philosophy: moderate the variability, then test with that moderated variability. 3 reviewers walk into the same restaurants. DESeq shrinks the ratings toward the city average. Bayesian shrinkage, the prior protects against small samples. Limma-voom keeps the ratings, but weights by precision. The frequentist approach, confidence drives the analysis. Edger moderates the variability, empirical Bayes, borrows strength across genes. They mostly agree, the same restaurants are excellent, the same restaurants are mediocre. In differential expression, the same genes are called significant. 3 methods, 3 philosophies, consistent conclusions.